allow it to rotate about y, and all other two directions it is not allowed to rotate. So press OK. Now again go to displacement, select the second point. So first I will take the points, select the second point. Now I will take the same constraint and press OK. Once I have defined the constraint, now it is acting as a simply supported beam. Now what I will do, I will go to force. So go to force. In the force, I will define force at its middle point. So once I will go to force, for the force, first I will select the point, then select the middle point. Once you have taken this middle point, now I will define the force in the z direction. As you can see, z vector to be in the downward direction. I will take force into the 100. As it is already in the downward direction, I am directly writing down 100. If it is in the upward direction, then I should have taken the -100 to get the force direction in the negative z. So here you can see it is in the Newton. So press OK, and I had defined a load of 100 Newton. Now what I will do, I will go to analysis and studies. Here I will go to file and new static. Once you have went to the new static, press OK. Press OK button. Once you have pressed the OK button, now go to run and start the analysis. It is saying that all analysis 1 results are already there, as I have run the analysis part previously. So what I will do, I will overwrite this and overwrite these results. Once now you can see the analysis is running, and once it is completed, now it is completed, I want to interpret the result. So go to result, define result value. Here you can see that in the quantity, whatever quantity I want to see, stress, displacement, strain, rotation. So first I will want to see the displacement, and it is going to be in the mm, and I want to represent the total overall magnitude. So if we go to the displacement option, display option, here I can see the deformed. If I want to see the deformed shape, if you don't want to see the deformed shape, you can uncheck it or check it to see the deformed shape. Now if you want to animate it, you can click over the animate also. So press OK and show. Now you can see that how it is animating. You can press the stop button at any particular point to see the deflection. Now the maximum deflection value is 0.19227 and it is in mm. So we can calculate this particular value also. I will just close it. Okay, I don't want to save these results. I can calculate this value. So before you can calculate it. How you can calculate it? Just close it. First you need to see the material property. So when you go to edit definition, here you can see the Poisson's ratio and the Young's modulus value. So just take these two values and I can calculate the maximum load value. Okay, just go to this particular thing. So this was my simply supported beam here, and I can calculate from this particular formula the complete value. So what is going to be the P value? P value is going to be 100 Newton. So just make sure that whether you are putting the units in mm or meter, depending on that delta max value will come in mm or meter. So put the value P in 100. Then what is this L? L is 100 mm. Okay. Then 48. What is the E value? E is the Young's modulus. E is the Young's modulus, and you can calculate E value from, you can take it in the megapascal directly. Once you have taken this megapascal, now what is this I value? I value is depending on the axis, so I will take it to be BD cube by 12. Depending on the axis, I will take it to be DB cube by 12 or BD cube by 12. So once you can calculate the value, you can match your results. Now I will put the cancel. I can see the stresses also. So again go to analysis and results. Here you can go to results, define result with. Here I can see the stresses also. So you can go to stress, megapascal, von Mises. Okay, in the display option, I can see the deformed shape. I don't want to animate it, so I don't click over here. Okay, and you can see the maximum stress value is what, 5.429. Okay. Okay. Maximum value is your 6 E1. Or what is this E1? E1 means multiplied with 10. So it is 60 megapascal is the maximum value, and it is occurring at the just the middle portion. So in case of simply supported beam, if you remember, the deflection and the maximum stress occurs at the midpoint. Okay. So thank you very much for watching this video.